Bearing capacity is the load which a soil can support without failure. Geotechnical engineers use their understanding of bearing capacity to design systems to safely transfer the load from structures to underlying soils. The loading produces compressive and shear forces in these soils. If the load is large enough, the shear forces induced in the soil will become higher than the shear strength of the soil. This results in failure. There are three types of bearing capacity failures that can occur. One type of failure is punching shear. This happens in loose sands, in thin layers of strong soils underlaid by weak soils, and in weak clays which are loaded slowly. Failure develops gradually in this setting due to the high compressibility of these soils. Little to no soil disturbance is seen at the surface when punching shear occurs, but structures experience high levels of settlement. Local shear failure occurs in cohesionless and loose to medium dense soils. This failure mode has a well-defined shear surface directly under the footing that may or may not be seen at the surface of the soil. Local shear failure happens gradually as the footing continues to experience settlement and movement along the shear plane. General shear failure occurs in dense cohesionless soils and undrained cohesive soils. General shear failure is characterized by a well-defined shear plane with clearly formed disturbances in the surface soils. This type of failure occurs suddenly and can cause significant rotation of the structure. Over the years, there have been several extreme instances of bearing capacity failure. One historic event involved the Transcona grain elevator constructed in Manitoba, Canada. The elevator design had overestimated the bearing capacity of the soil and underestimated the load from the grain. This led to the structure experiencing a sudden and dramatic general shear failure. Engineers have developed methods to safely support structures and transfer loads in soils with low or insufficient bearing capacities. One method is to distribute the load of the structure over a larger surface area. Mat and raft foundations are used for this application and usually span the entire footprint of the structure they support. Another option is to bypass weak soil layers and transfer loads to stronger layers or even bedrock below. This is accomplished with deep foundations. There are several types of deep foundations which are generally categorized as driven piles, drilled shafts, and auger piles. Soil improvement can also be used with shallow foundations to get the necessary strength for structural support. Soil improvement technologies strengthen and reinforce existing soil structures at sites to increase bearing capacity. There are many different options for soil improvement, with new technologies being developed regularly.